In today's video, we're going to create Flappy Rectangle. This is a beginner-friendly tutorial, and I guarantee you will learn many of the basics needed to build 2D games in Godot. You will be using essential nodes like Character Body 2D, Static Body 2D, Collision Shape 2D, Area 2D, and many other functionalities. We need to create our player. Click Other Node, and add a Character Body 2D. This node is specialized for characters that need to move and collide with objects based on code we write. Next, add a Collision Shape 2D and a ColorRect as children of the player node. The Collision Shape 2D defines the physical area of the player, while the ColorRect is just the visual representation. Select the Collision Shape 2D, choose the rectangle shape in the inspector, and resize it to cover the ColorRect. Once that's done, save your scene. Now, let's create a script for the player. Godot automatically provides a default template for Character Body 2D, so we will reuse and modify this code. First, look at the if statement that checks if the player is on the floor to apply gravity. In a Flappy Bird style game, there is no floor and gravity should apply all the time. So, we can remove the if condition and just keep the gravity logic. The code uses getGravity and multiplies it by delta. Multiplying by delta ensures the game runs at the same speed on every computer, regardless of the frame rate. Next, there is an input check for the UI_accept action, which also checks is _on_floor. This logic is for typical platformers where you can only jump from the ground. For our case, we want to jump in midair, so remove the condition that checks for the floor. You might notice that the jump velocity is added as a negative value. This is because, in Godot, the negative y-axis points upwards and positive y points downwards, which is opposite to the real world. The rest of the template code allows the user to move left and right. We don't want that. We want a player to move forward automatically. So, remove the input direction code and simply increment the velocity.x with a speed variable so it traverses right constantly. Finally, move_and_slide is a magic function that moves the player using our updated velocity. After moving, we need to check if we hit anything. We can use getSlideCollisionCount. If this returns a number greater than 0, it means we collided with a wall, so we will reload the current scene to restart the game. That's it for the player. Now we need to add obstacles. Create a new scene and make it a 2D scene. Rename the root node to Pillar. Add a Static Body 2D as a child. A Static Body 2D is a physics object that is meant to stay still or move only when we explicitly tell it to. It doesn't react to gravity. Add a Collision Shape 2D and a ColorRect to the static body. Select the rectangle shape and resize the collision shape to cover the ColorRect. This will be our top pillar. Select the top nodes and group them so they move together. Adjust the position to make it the top obstacle. Now, copy and paste that entire structure, rename it to down, and move it to the bottom to create a gap. We need to detect when the player passes through the gap. For this, add an Area 2D node. Unlike the static body, an Area 2D doesn't block the player. Instead, it detects when another object overlaps with it. Set the shape to a segment or rectangle and resize it to fit perfectly between the top and bottom pillars. Now, save the scene and attach a script to the main pillar node. Click on the Area 2D node, go to the Node tab, Signals, and connect the body exited signal to the script. This function triggers whenever an object leaves the area. In the script, we first define a custom signal called pointScored. Inside the body exited function, check if the body exiting the area is named player. If it is, emit the pointScored signal, so the main game knows we passed an obstacle. Let's bring everything together. Create a new scene and rename the root to main. Add a timer node and a canvas layer. A canvas layer is used for UI elements like scores. It stays stuck to the screen even when the camera moves. Add a label as a child of the canvas layer to display the score. Now, Drag and drop the player scene into main. Save the scene and add a script to the main node. In the script, we need a reference to the pillar scene. You can drag and drop the pillar scene file into the script variable. Select the timer, go to Signals and connect the timeout signal. We will use this to spawn a new pillar every 1 second. Inside the timeout function, we first instantiate the pillar. Instantiation means creating a copy of the scene from memory to put into the game world. We need to set the pillar's position. For the X position, get the player's current X coordinate and add some pixels so it spawns ahead of them. For the Y position, we can randomize it, for example, between 0 and 100 to make the game challenging. We also need to connect the point scored signal we created earlier to a function in the main script. This function will simply increment a score variable and update the label text. Finally, add the new pillar instance as a child of the main scene, so it becomes visible. Don't forget to call this spawn function inside the timer loop. Now you can play the scene. Continue experimenting because the best way to learn is by doing. Thanks for watching.